And it's not that hard to go from a parallel in, serial out to a multi-purpose register, meaning that we can have serial inputs, parallel inputs, and have parallel outs and serial outs. So I guess let's just kind of run through how each one of these would work real quick. Let's do a parallel in, parallel out. So if we wanted to write the sequence 1101, so we'll get the booger picker and 1101, and we're going to load it, and then we need a clock signal, right? We need a clock signal to program our flip-flops. And there's our signal. And so we've got it available. We went parallel in, and we've got our data available in a parallel output fashion. And now let's, if we wanted to clear this, the way that this is set up is we'd have to have a few clock pulses first. Just as a quick aside, if we wanted to be able to clear it quicker, how do you think we'd do that? Well, given the configuration we have right now, we could actually have a bigger multiplexer, maybe like a 4-to-1 multiplexer, and that 4-to-1 multiplexer, one of them could be all zeros, and so we could have a configuration where the mux would go to the third position and it would just write zeros to everything, or maybe ones. It's kind of how you want to design it, right? Anyway, now let's try and do serial in, serial out. So if we want to do serial in, that means we want this connection right here, and that means that our mux needs to be in the 0 position, right? And so that means the load has to be 0 for this case. And now if I want to send in the sequence 1010, I'll send in a 0, then a 1, then a 0, and then a 1. And so now you can see that our serial out is sending out a 0, then a 1, then a 0, then a 1. And look at that. I left my D in at a 1, and so it's actually been shifting in 1. So something to be careful of if that's not a behavior that you want. So we did that. Now let's do serial in, parallel out. Well, we really don't have to do anything. In fact, if you're paying attention, you might have already saw that behavior happening, right? So let's do 1010 again. So we shift in a 0, a 1, 0, and a 1, and just like the serial and parallel register that we looked at before, we've just got it broken out of each flip-flop, and there's our 1010 in a parallel fashion. So there's that, and we can clear it out. And the last thing is the serial in, parallel out. Oh wait, nope, parallel in, serial out. So to do that, right, we need to get ready to load and say we're going to do 1111. We get a clock pulse, and there's all of our ones. We turn off load, and now we can start shifting it out through serial. So there's our 4 ones that just got shifted. So as you can see, these registers, right, they do take some timing considerations, and you have to know how many clock pulses or how many clock edges you have to have in order to fully get your data. But that's just kind of part of being a digital engineer, is being able to look at these, know how the timing is going to work out, and design any receiving systems to work around that or manage that.